Hello, everyone. My name is Sergio Sastre. I've been doing Android development for over 8 years, and one of the things I really like about development is testing, and that's why I'm here today to talk about property-based testing and how it can help with our current testing approach. But before going deep into property-based testing, let's take a look at the most common approach for tests that is called example-based testing. So in example-based testing, the most likely is that we have tests that specify the behavior of a piece of our software by writing examples of it. But in order to explain this better, I'm going to show you some code. Yeah. So for example, we want to test that a string is a palindrome. So a palindrome is when a string, if you read it from the beginning to the end, and from the end to the beginning is still the same. So in this test, actually, we are using an example. Yeah, this 1221 is an example that represents a string with an even number of characters. But we could also use another example, like this one, 12821, that represents an odd number of a string with an odd number of characters. But we could also use an empty string, which is also a palindrome. And as you can see, we come up with examples, and we use those examples to verify the behavior. So in order to explain the problem of this approach of example-based test and how property-based test helps with this, I'm going to show you during this tech talk 2 examples. So the first one is a strong password validator. Yeah, basically, we input a password, and if it does not meet the requirements of a strong password, then you get an error message. And the second one is a text editor, so you can type some text, you can undo the text that you have typed, and you can redo what you have undone. So let's start with the strong password validation. So usually, you would have, if you are using live data, something like this in your view model. You have a method, click sign up button, and then the password error is, you can set the value by calling this password validator validate. But we're going to focus on this password validator. So in order to test this, we're going to write one test for each requirement of a strong password validation. So let's go through it. Yeah. So for example, our strong password needs to have at least 1 digit. So we write a test like this. Yeah. Validate that ABCDEF must contain, and we show when it fails because it has no digit, then we show that error message must contain digits. The same applies for uppercase. Yeah. So if we want to validate 1, 2, 3, 4, 5, 6. Has no uppercase, so the error must contain uppercase letters. And here we already see some commonality. Yeah, there is always the same pattern. So we validate that given a password, the output contains the expected error. So one tip here, because we are going to validate more and more requirements that look like this, is to use, for example, unit 5, in concrete, to use the so-called parameterized test. Yeah, so you basically have only one test, and you pass parameters to it. So in this case, this test method contains 2 arguments. So the values for the arguments pass through the CSV annotation. On the left of the comma, we have the password, and on the right, the expected error message. And as you can see here, every single line is a test for a requirement. So if we go on, at least 6 characters. Yeah, so we just add one more line under the CSV source annotation with the password containing less than 6 characters and the expected error. One more requirement, again, one more line with a password containing blanks and expected error, and go on. Yeah, so it's very easy to add more tests for more requirements without repeating the code. And it's still very readable. So yeah, we know that anyway, these parameterized tests are example-based tests. And the question remains, yeah, are example-based tests enough? So let's take a look, for example, at the uppercase letter validation. Yeah, imagine that we're using a regex. Yeah, and at some point, you are doing some refactoring, you're in a hurry, and yeah, you just make a change here, and it starts validating lowercase instead of uppercase. This looks like something very easy to oversee in a code review, to be honest, and it could happen. But anyway, we have written tests, yeah, so we are safe. So doesn't matter, our CI will run the test, and it will be for sure red. So we run the test on the CI, and it's green. So we know that something is wrong. We have seen it. And we want actually to find out why the tests are green. Because for uppercase, we're actually validating lowercase. So we take a look at the uppercase example. And since the uppercase validation is actually validating lowercase, we could add the same sample, so 1, 2, 3, 4, 5, 6, for lowercase validation. And the test should be green. So we do it, and of course, the test is green, so it makes sense. And then it's when we have this facepalm moment, we realize, OK, of course, yeah, the example that we are using only contains digits, so it's going to pass always. I mean, it's going to fail the regex always for uppercase or lowercase, doesn't matter. It always shows the error. So we need an example that does not fail this regex, an example with lowercase letters. So we come back to the uppercase, and instead of the example with only digits, we got an example with only lowercase. And now it reads as follows. If A, B, C, D, F, all lowercase, has no uppercase, what is true, the error message must contain uppercase letters. It's not happening, what basically means that the implementation is wrong. And yeah, basically, we have identified the problem, that our example was not enough. And we should add one more example to really verify that the code is doing what it's supposed to do. So let's recap the problems with example-based tests. Actually, yeah, I would say it's insecurity. Yeah, you pick an example, you're not sure whether this example is good enough. And yeah, you can keep adding more examples and more examples, but you are never sure whether all the examples you have added are enough. What you know for sure with example-based tests is that only for those examples, the code is correct. So we already identified the issues, but how can we mitigate them? So let's go back to the example-based testing definition. Yeah, and yeah, especially this. So our tests specify the behavior of our software by writing tests, by writing examples. But with property-based tests, what we are going to do is to generate those examples. So we are not picking examples. They are generated, and they are generated semi-randomly. And not only one. We're going to generate 1,000 of them. So if we go back to our palindrome example, yeah, the property test counterpart will look like this. Yeah, and the main difference is that, yeah, on every run, we're generating 1,000 new strings. And these strings are semi-random. Yeah, they are based on a set. They are not picked. So if we run this test 10 times, it will validate 10,000 strings, because it doesn't generate the same values on every run. However, this syntax is not possible with JUnit 4, also not possible with JUnit 5. So don't worry, because there are some libraries that actually provide the capability to run property-based tests. And I have actually experience with this too. jQuick, that was created by the initiator of JUnit 5, and the syntax looks very similar. And then Coates, that is the most popular Kotlin testing library. So let's go through the pros and cons of each of these libraries. So from jQuick, the integration is very smooth via Gradle, also from the IDE. So you still, when you write jQuick test, you still get this green arrow next to your test that you can click, and then the test will run. With Coates, you need the plugin, because otherwise you can only run from the command line. Then another thing that I really like about jQuick is that full feature. So everything you can imagine that is possible with property test can be done by jQuick. And if it's not possible yet, it will be very soon. And Coates is always like behind jQuick. Yeah, they are copying the features from jQuick into Coates. And one that I actually like about jQuick is that once the test fails, it will save this seed, and every time that you run the test again, it's going to fail and fail and fail till you fix the error. That's not the same with Coates. So it could be that you run your test, they are red. You run them again, they are green because generated a different set of examples, and they are still passing. However, in the next release, they are copying a lot of features from jQuick, like this one that I've mentioned, and also stateful testing. I'll talk about that later. So they are releasing that in the next release. I don't know when it's coming, but maybe it's worth for you to know that it's going to happen soon. So the next one is Kotlin support. Yeah, in jQuick, it's a Java library. Of course, you can write tests in Kotlin in Java, but there's one thing that I don't really like too much. That is the nullable support. Especially for non-top levels. So what I mean with this is that if you you want to generate a string optionals, nullable strings, you can use a string optional. It's fine. It's going to work out of the box. It's going to generate also nullables. But if you want to use something like a list of nullables strings, you have to use this annotation, what is not very Kotlin-like. Yeah, you have to use this with null annotation. Yeah, that's it for jQuick, but for Coates, it's Kotlin first, so no issues like this. And the last but not least is the jQuick does not support Kotlin multi-platform, and Coates does, and also for PBT, if I'm not mistaken. So if you have you are using Kotlin multi-platform, just keep with Coates, And as I mentioned before, a lot of features from jQuick are being copied into Coates, so it won't be an issue in the close future. So, OK, we already know the framework. So now I want to know how to write property-based tests. So I'm going to use jQuick because the annotation is very similar, and the style, the syntax, everything is very similar to JUnit 5, and therefore also to JUnit 4. And we are going to start with, again, the strong password validation. And for that, we'll write the property-based test for the uppercase password validation. And we will see how, by writing this test, the issue that we have encountered previously with example-based test is going to be caught. So independently of the framework you are using, there are 3 steps. When writing property-based tests, the first one is to define the property. In this case, it's very simple because the requirement reads like a property. You have a password without uppercase, then show this error. So easy peasy. The second one is to create a generator, because we want to create basically a string without uppercase characters. For that, basically in jQuick, we need the provide annotation to say, hey, this is a generator. And then we have to use this arbitrary thing that you see there that basically generates random strings that do not match these regex. No, that matches this regex, that is, it does not contain uppercase. And last but not least, is to test the property. And jQuick, to define that the test is a property test, you have to use this property annotation. And to pass the generator, we have to use this for all annotation as well. And by default, it will generate 1,000 examples, semi-randomly with a seed. But if we don't want jQuick to generate 1,000 examples, we can say, OK, just give me generate 100. And we can do it like this. It's also configurable in code test, the number of examples that will be generated, so done differently, different syntax, and so on. And last but not least, coming back to the property that we have defined, in jQuick there is something like label. Label is very similar to display name in JUnit 5. And basically, we want with this to change the name of the test displayed in the report. So this is an overview of the property-based test with the generator and everything. Yeah, and if we click on the run button, we get the following report. So yeah, you can see at the top that actually the test failed. So it found the error. And then we had something very interesting that is a specific jQuick report. And I'm going to scan it and go through it, so no worries. Let's understand what's there. So first of all, the original error is the same that you would get in JUnit 4 and JUnit 5. And then things become interesting. Yeah, you have this, the original sample, that is the one that actually made the test fail. And then we have the shrunk sample. So let's find out what this shrunk sample is. So yeah, as I mentioned, the original sample was P, but could be any other one because PBT generates semi-random inputs. So instead of P, it could have been something like this. And if you recall correctly, the test failed because it contains lowercase. Actually, this string contains a lowercase. At the very end, there's like a lowercase o, not very, very end, but close to the end. And that's why it's failing. So that's one of the reasons why we have this shrunk sample. Is the simplest example that fails for the same reason. And this jQuick, as well as Codes, have this feature. This basically, once the test fails, they will try to find what is the simplest example that is the most understandable. And it will definitely help you to understand why your test is failing. So that's one of the features of property-based testing of some of the frameworks. But yeah, on every test run, new examples are generated. Yeah, so we run it again, we get another example. We run it again, the test passes, because with those examples, it's pretty fine, yeah? It didn't find any error. Yeah, so basically the idea is that on every run, it uses a different seed. So it generates new examples. So the jQuick report also contains the seed that was used when generating these examples. And it would be very nice if we could provide this seed to the test, because it will generate always the same examples. It will always produce the same results. So how can we use the seed? We got our test here. And if we take a look at the property annotation, then we just have to add the seed there. This is very good for testing locally, because you identify the bug, you copy the seed, and then you try to fix the code. Because every time that you are going to click on the run button, it's going to generate the same examples. And that way, you will know when you have really fixed the bug. Do not forget, however, to remove the seed before you push it to the CI to continue generating random and random examples. So it basically means, since we can use a seed, the tests are not flaky, it's reliable, we can reproduce reliably the results of a failing test. So next are the edge cases. Yeah, it's also part of the this jQuick report. And here we can see that there are 3 edge cases, and jQuick has run one of them before failing. If we want to know what are these edge cases, the generators, these arbitraries, have a method that is called edge cases that you can always call. This is specific to jQuick, of course, because of these arbitraries. And you will know what are the edge cases that jQuick has considered. Yeah, so in this case, the mean valuable character, the empty char, and also the space char. And yeah, that's basically it from jQuick. The main features, just to recap about property-based tests, are like shrinking, so finding the simplest example that will make your test fail. Then, that we can always use seeds to reproduce the bugs that we have encountered by using property-based tests. And also that since you are running and generating thousands of examples, in the end, the edge cases are going to be considered. jQuick will run them, I guess, first of all, some of them, but it will go through all the edge cases that it has detected, even in these 1,000 examples. But other frameworks may not. So what else can jQuick do? There is also something that I find very interesting that is called stateful testing. Still not available in Codex, but is coming in the next release. And yeah, in order to explain that, I'm going to use the text editor example that I mentioned before. First of all, we have our model that basically contains the current text, that is the one displayed on the screen, and then a list of undo and redo actions that contain the text to be displayed when we undo or redo something. So then we can perform some actions on this model. Yeah? The most important is to identify actually these actions. So we can change text, we can undo, and we can redo. And this is important because we got an state, we perform one of these actions, and we get into another state. So it's like a state machine, yeah? And that's basically stateful testing. So you perform actions on your state to go into another state. So we need to transform these actions into actual requirements. So it looks basically something like this. These are the requirements of our application, our text editor. And we're going to start again with the text change. So at the start, the undo button is disabled. And when we start typing, the undo button becomes enabled. Because on every text change, one more undo action becomes possible, up to 20. And then we have the undo action. The redo button is now disabled. So we basically start undoing, and the redo button becomes enabled. So we can redo the undone actions. And on every single undo, we show the previous text. And after undoing 20 times, we cannot undo anymore. So the undo button is disabled. And then we have the redo action. We've undone 20 actions. We can redo them by clicking on the redo button. And after doing 20 times, we reach the maximum. So the redo is disabled. And that's it. Those are our requirements. And we may notice that we can undo and redo 20 times maximum. It's a requirement of this text editor. So let's take a look at how the corresponding test for this text change requirement would look like. Yeah, so we go to our own text change test that would look something like this. Our example-based test would look something like this. So we cannot undo more than 20 times. because what we are actually checking here is that if we undo, we change the text 21 times, still you can undo only 20 times. But let's be honest, yeah, you can insert and delete text 21 times, but that's not what would happen usually. Yeah, you would usually start inserting, deleting text, you undo in the meanwhile, you redo again something. So we need to ensure that at every moment the state the requirements of the state are met, and that you can never undo more than 20 times. And that's where property-based test comes useful, because you can generate those actions randomly. So sometimes it will type text, sometimes it will undo, sometimes it will redo. So let's see how we can do actually this. And in order to explain that, I'll go action by action. Yeah. So first of all, again, text change. So we need to create a class for this. Yeah, let's explain it part by part. Yeah. So the text change needs to inherit from a jQuick action. So this action that you see is from jQuick framework. And then we have the run method that we have to override. And here there are several things happening, pretty straightforward. Yeah. So we check that the undo actions count before changing the text. Then we change the text, and then we assert that in the current state, the number of undo actions is 1 more than before, but up to 20. And the second requirement, that no redo actions are possible. That's how most text editors work. Yeah, whenever we change the text, we cannot redo anymore. Yeah, so the redo button is supposed to be disabled. And that's for text change. And that's how it looks all together. So easy peasy, let's move on. Then comes the on-undo action. It's very, very similar to the text change action, but there is one peculiarity. It's this precondition, yeah, which is a method that we can override. And this precondition basically tells the generator that if the model is in a certain state, do not generate or perform this action. So if there is nothing to undo, do not generate an undo action. So because the button is disabled, the undo button. And yeah, apart from that, everything is similar to the text change action, follows the same pattern. And the redo looks very similar to undo, so I'm not going to bore you more. So let's go to the next point. That is, yeah, the semi-random action generator. So now what we are going to do is we are going to define a generator for the arbitrary actions. Yeah. So we got, yeah, the random text chain. So we generate a random string and pass it. We map it to generate a text change action with that random string. And for the undo and redo, we also have to use these arbitraries to make it arbitrary, because it's one of the requirements. If you want something to be generated randomly, you have to use arbitraries. So now we want to take only one of those actions, generate one of those actions randomly. So we use arbitraries one-off. So pick me one of these randomly. And then we have to use the provide annotation for the generator, as we saw before. And here is like, we don't want only one random action, we want a sequence of random actions. So we use these arbitrary sequences. So now, yeah, we are done with the semi-random action generation. It's time to write the property test. So, yeah, as we saw before, for that we need the property annotation. And we also pass the generator through the for all annotation. So as before, and the test itself is just a method to call run the arbitrary sequence of actions that we have passed as an argument. It's as easy peasy as this. And this is what it looks like all together. So at the top, we see that we have defined For every action that we can perform on the model, we have defined a class. Then we have the generator with the provide annotation. And then we have the property test with the property annotation. So that's what a property test with jQuick looks like, a stateful testing methodology. So let's recap about the stateful testing with jQuick. So first of all, you have to identify the actions that you can perform on the model that will bring the model to another state. Then, yeah, we can define some preconditions in the actions not to generate them. And then also one peculiarity of stateful testing is that the assertions do not happen on the test itself. They happen in the class, the action class that we have defined on every single action, because every action has its own requirements. So some pros and cons of property-based testing. Yeah, because there are pros, but there are also cons, as with everything, I would say. So let's start, I would say, with the pros. Yeah, so your tests are more robust because you are not just testing a few examples. As you would do with example-based tests, you are testing many, many more. And on every run, more and more and more. So you gain more confidence if those tests, after several runs, are still green. The second one is that they are not random. I mean, they are random, but they are still deterministic, because you can always use the seed to reproduce the same, to generate the same sample of tests, the same set of examples, and then the results of the test will be always the same. And also important is that it will help you to cover also edge cases that you might forget, and everybody forgets, yeah. For example, when testing ints, I don't know about you, but me, I'm not the guy who is going to test the min value and max value that integers provide. It's not something that comes to my mind first. However, there are also some cons. Yeah, yeah, let's go through all of them, yeah, but one by one. So the first one is that sometimes it's hard to find properties. How can I say this? So as we saw in our previous example with the uppercase validation, yeah, it was pretty easy because the requirement reads almost like a property. But it's not always the case. Yeah? For example, if we have a method that reverses a given string, how we would do that? Yeah. So the problem is that basically, the requirement does not read as a property, because what is a reverse string? Yeah, a reverse string is basically if you start from the beginning to the end and from the end to the beginning, the string should be the same. No, I'm getting confused, sorry. But, sorry. Yeah, exactly, sorry. The requirement for a reverse string is that it is the same as the original when you read it from the last character to the first one. And that's much harder to translate into computation terms. Yeah, that's, you cannot translate it as a business property. It's like, it's not like before. And so it basically means you cannot use this pattern, but there are other properties that I'm going to use. So for example, another pattern that you can use is test oracle. That's, for example, when you have an algorithm like a bubble sort, and you know that it's sorting correctly, and you want to you want a more performant version of your bubble sort. And to verify that the more efficient algorithm also sorts correctly, you compare its results to one of the bubble sort, because you know that it's sorting correctly. But here, let's assume that for the reverse string, we don't have a method that actually exists in Kotlin to reverse the string, and there's no method that you can take as a base and say, OK, this is more performant. So we rule this pattern also out. And then we come to the next pattern that we can use to find properties. So this is called invariant function. Yeah, what does it mean? It's when some attribute remains the same after a transformation. So if we reverse a string, its length still remains the same as that of the original. Yeah, looks like, honestly, not sufficient. Yeah, it's true. Yeah, you can use it. You will define a property, but I still have the feeling that it's not enough. Yeah. So we keep finding properties. Yeah. So we have already a test that would look like this, property-based test. So easy peasy, pretty simple. But we are gonna check another one, and this one is very interesting. That is called inverse functions. So inverse functions are functions that, for example, are functions like zip and unzip, encode and decode, and reversing is also one of them because you have a string that is, for example, 1 to 3. If you reverse it, it's 3 to 1. If you reverse it again, so twice, you get the original one, 1 to 3. And this fits perfectly our case. So, and looks actually like good enough. Yeah, we have already 2 properties. Looks like, yeah, I'm confident enough that it's going to work. So the test, we take this property also. We write the test that looks like this. And yeah, that's what we have. We have 2 property tests. And looks like we are done with this. So the next con is the properties are not always sufficient. Let's imagine that we got the wrong implementation. So instead of really reversing a string, we are returning the original one. Yeah. So we expect our property-based test to fail. So let's go through this. Yeah, one by one. So the first one is the invariant function test. So our string reverse translates into this. So this length equals this length. So it does not fail. OK, it's not a problem. This property test is still passing, should not, because the implementation is wrong. So let's analyze the second one. Yeah, so string reverse is this. So we got this reverse, what is also this, equals this. So yeah, it looks like the test will still pass. And we know that the implementation is wrong. So our property-based tests are failing. And this actually is something that is very easy to identify with an example-based test, because if you write, I don't know, an example-based test with input 1 to 3, and expectation to be 3 to 1, you would see that it's failing. And last but not least, I'm just at the end, running out of time. Yeah, is that yeah, property-based tests, as I mentioned, they are generating a lot of tests, like 1,000 by default. You can configure that. But they run more slowly. Yeah, so if they don't run 1,000 times more slowly, if one test takes like 50 milliseconds, 1,000 tests will take probably 1 second, so not 50 seconds, not 1,000 times longer, but it will definitely take longer. One way to avoid or to mitigate this, better to say, is to just say, OK, run this 100 times and not 1,000. Anyway, I think this defeats the purpose of property-based testing. So I don't recommend to do this. So we are just at the very, very end. Let me give you some opinionated advice about property-based testing. So yeah, I would use property tests when the requirement reads like a property, as we have seen already with the password, because it's very easy to write and very easy to understand. I would also use property tests for code that is used widely. So utility methods, I don't know, everybody has, for example, like dates formats that you want to convert from date format to another one, things like that. I would recommend to use it. And I would also recommend not to use only property-based tests. Always use also example-based tests, because as we have seen, there are also problems with property-based tests. And actually, if you are doing TDD, you can always write not property. You can write example-based tests, and then in order to ensure that you have covered all the edge cases, you can write property-based tests, especially to ensure that the code is very robust and bug-free. And yeah, so basically that's it. I think we have almost no time for questions. Yeah, I'm sorry, but I will be here around if you have any question. I wrote already a blog post about this. I'm also writing a lot about the screenshot testing, and I also have some code examples in my GitHub. About property-based testing with Quick. So that's it. Thank you very much for your attention.